Hey fifth graders, how you doing? It's Saturday morning. I'm here live. Oh, Georgie's gonna show you his new trick. Um, we are here in the playroom at our house in Kirkland, and we are excited to get into lesson 2 in module 3. We are going to continue working with equivalent fractions. So you guys, on Friday we worked. You said it. Friday we worked with a few different strategies as we were generating equivalent fractions, and today what we're going to be looking at are improper fractions on the number line. So stay tuned, it's going to be great. Here we go. Hey kiddos, here we are. I just wanted to give you guys a snapshot of what is going on in Module 3. As we talked about on Friday, it's a quick module, unlike the module that you had in 4th grade where your fractions, I think you studied for like 39 lessons. So the entire Module 3 is only 16 lessons here. We will have our mid-module assessment. You can see that right here. We will have our mid-module assessment after lesson. I don't have my pen hooked up, so I'm just doing this with my mouse pad. Georgie's embarrassed. I'm doing my best, Georgie. We will have our mid-module assessment right after lesson 7. And as you guys can see, all of our lessons, as always, are organized into topics. Topic A, why isn't this zooming out? Topic A is equivalent fractions. That's lesson 1 and 2. Topic B is making like units pictorially, meaning just drawing. We're going to be doing a lot of different models. So I think you guys will enjoy that. That will take us from lesson 3 through 7. And then topic C, we're going to practice making like units numerically. So instead of drawing our like units, we're then going to, just do a more traditional quote-unquote standard algorithm, and that will be lessons 8 through 12. And then we have this kind of funny topic that's called further applications, where we use we're going to be adding, Georgie's looking forward to that. You can hear him laughing in the background. We're going to add and subtract, multi-term, and then just like kind of word problems here. So that'll be lessons 13 through 16. As far as this week goes, on Monday we are going to be covering lesson 2, and then Tuesday we are going to be covering lesson 3. Wednesday we are dedicating our entire time to science. We are doing our motion and design challenges. Mr. Calamir's, yes, does that sound exciting?
Science.
Honey? Yes, science. So we will not be getting to lesson 4 until we get back in 2018. Oh gosh, it's really hard to write without my pen. I need to get that hooked up. But then just keep in mind, we come back from winter break on a Tuesday. So we're going to have our mid-module assessment pretty quickly right after mid-module break because this is such a long unit. Okay, so let's just get into some work with making equivalent fractions. It's going to be fun. Stay tuned. Okay, kiddos, let's look at number 1. Here we are going to show each expression on a number line and solve. So we are right now just working with numbers that have common or like denominators. Denominators, again, is the downstairs number. So 5 and 5, you guys all know those are the same number. So we're just going to add 2/5 and 1/5 on a number line. Our interval here is going to be 5 because our denominator is 5. And this, just be very, very thoughtful when you are dividing your number line into intervals. We need 5 intervals. Not necessarily 5 lines, but we need 5 intervals because we're dividing the space between 0 and 1 into fifths. So I'm going to try to do this as evenly as possible. We'll see how it goes. So here's 1 interval. Here's 2, 3, 4, and 5. So let's make sure we're good. Okay, so we have 1, 2, 3, 4, and 5. We should have 5 equal intervals here. They're not exactly equal, but let's just use our imagination. So here we have 0/5, and then we have 1/5, 2/5, 3/5. Kendi was going to tell us that's 4/5. And another way to say 1 is 5/5. Okay, so now we're just going to use our jumping cursor to add 2/5 and 1/5. Okay, so we're starting with 1 2/5. Okay, and then we're going to add a 1/5. And then we end up right here. So what we've just learned is that 2/5 plus 1/5 is equal to 3/5. Okay, cool. So that's not rocket science, but you guys, this is, I'm going to zoom out to clear that. This is going to really come in handy as we start working with more and more complex numbers. So let's just do one more here. We're going to show, this is not always so user-friendly. We're going to show each expression on the number line, and then we're going to solve. This one, D, actually is really interesting. So let's check D out. First, we're going to make our number line. Zip. And this number line, we'll start with 0. And let's look back at our problem and let's think about our intervals. The denominator is 4, so we need intervals of 4. So I'm going to go ahead and make, we're going to put whole number 1 here, and then we're going to put whole number 2 here. And the space in between each whole number needs to be divided into 4 hopefully equal chunks or 4 intervals. Keep in mind that doesn't mean that you're just going to mindlessly draw 4 lines. You need to divide each space between your whole numbers into 4 intervals, let's see. So we have 1, 2, 3, 4 here, and then we have 1, 2, 3, 4 here. Just to keep you on your toes, in order to divide the space in between each whole number into 4 equal intervals, you're actually drawing 3 lines. So you have to really be mindful here. Okay, so this is 2 times 3/4 plus 1/4. Another way we could say this is 2 copies of 3/4 plus 1/4. Again, we're still working with like denominators. Life is not always going to be this sweet. Pretty soon, very soon actually, we're going to have unlike denominators, and we're going to have to do some work before we can even add them together or subtract them. So today, life is easy because these denominators are the same, which means these fractions are in the same language. So first, let's make 2 copies of 3/4. Okay, so first we're going to make a jump. We're going to start with 3/4. Okay, so we have 1/4, 2/4, 3/4. Okay, so that's 3/4. And then we're going to make a copy of that, meaning we're going to do it again. Okay, so we have 3/4, and now we're going to jump 1/4, 2/4, 3/4. This jump is 3/4. This mark, though, is not 3/4. What is it? Let's count how many fourths our stopping point. Let's see how many fourths we're at here. So we have 1/4, 2/4, 3/4, 4/4, 5/4, 6/4. Okay. So our stopping point here is 6/4, but we still need to add 1 more fourth. So we're going to jump, boop, 1 more fourth. We're going to end up at 7/4. Interesting. So we made 2 copies of 3/4. We landed at 6/4, and then we added 1 more fourth, and we arrived at 7/4. Here's the cool thing about 7/4. First of all, we consider 7/4 to be an improper fraction. I'm not labeling that point on the number line is 7/4. I'm just going to kind of break 7/4 down here. 7/4 is an improper fraction, meaning the top is larger than the bottom. 7/4, as you guys well know, went beyond one whole number. 7/4 is larger than one whole number. It's even pretty close to two whole numbers. We can, 7/4 we can rename as its whole number. How many whole numbers did we pass? 1. And then we have a fraction of a whole number as well. How many fourths is 7/4? Well, it's 1, 2, 3. We can rename 7/4 as 1 and 3/4. These two numbers represent the same amount. Fabulous. Kiddos, we're going to check out number 3 next. So in lesson 2, we are really exploring what it means to be an improper fraction. You guys know from 4th grade that when we have an improper fraction, the numerator here is larger than the denominator, which means that this fraction actually represents a number that is larger than one whole. Sometimes an improper fraction will represent a number that is larger than two wholes. So what we're going to do, and that's whole, W-H-O-L-E. So here in number 3, we're asked to express each of the following as the sum of a whole number and a fraction. We're going to be kind of breaking apart these improper fractions into the sum of a whole number and a fraction as to whatever is left over. And then show part C and D on a number line. We're going to take a look at B, so we'll put B on the number line. So here we have 9/2. We're going to rename 9/2 as 2/2. We're just going to decompose that 9. 2/2 plus 2/2 plus 2/2 plus 2/2. Okay, let's update ourselves. Where are we here? How many halves do we have? So we have 2, 4, 6, 8 halves. We're renaming 9/2. So we decomposed 9/2 into 2, 4, 6, 8 halves. And we have 1, thank you, Gabby, 1/2 left over. So 9/2 is the same as 2/2 plus 2/2 plus 2/2 plus 2/2 plus 1/2. You guys are probably already thinking about the fact that we can now rename 2/2. Another way that we can think about 2/2, and let's just think about those squares that we were looking at yesterday. If I have one whole square and I divide it into 1 2/2, and we're shading both halves, how much shaded square do we have? Well, we have 2/2 of a shaded square. We also have one whole shaded square. Wow! So we can rename 2/2 as 1. We can rename 2/2 as, thank you, Eric, 1. We can rename 2/2 as, Tanner, 1, thank you. We can rename this 2/2 as, Alex, 1. Beautiful. And we're just going to keep our 1/2 as is because it's just such a beautiful fraction. Okay, so now we've renamed our 2/2 as 1. 2/2, 1, 2/2, 1, 2/2, 1. Now let's rename 1 plus 1 plus 1 plus 1. Here is an excellent refresher from, I don't know, do you guys do this in kindergarten? 1 plus 1 plus 1 plus 1 is, thank you, Adve, is 4. So now we can rename 9/2 as 4 wholes plus 1/2. Interesting. Let's go ahead and show that on a number line to just beautifully represent this improper fraction. Okay, so here's our number line. Over here we will have 0. Over here, what number shall I have? We're trying to represent 9/2, which we just renamed as 4 plus 1/2. What number should I put all the way over here, Kylie? Kylie just whispered 5, and Kylie, you would be correct. So this number line represents numbers 0 through 5. So we're going to mark our whole numbers. So we have 1. We have 2. We have 3. And we have 4. Wow. I think that is actually, those are pretty even intervals. I'm pretty proud of that work there. And then, you guys, our denominator, that number that lives downstairs, dictates how we are going to divide our intervals. Our denominator here is what? Ira, thank you. Ira is telling us, oh, Mrs. Calameres, our denominator is 2, so our intervals in between each whole number need to be 2. Keep in mind, again, friends, that doesn't mean that you're just going to mindlessly slap 2 lines in between each whole number. That means that you need to divide the space between your whole numbers into 2 equal pieces. If I just mindlessly slapped 2 lines in between 0 and 1, I would not have divided my space between 0 and 1 into 2 equal parts. So be very careful of that, you guys. That's pretty tricky. Okay, so now, because Ira was so helpful in telling us the denominator here is 2, I need to divide my space in between my whole numbers into 2 equal sections. Beautiful. So I have 1, 2 equal sections, and let's continue that work here. 1, 2 equal sections. Beautiful. And then between 3 and 4, we're going to divide that into 2 equal sections, or into halves. And then in between my 4 and 5, we're going to divide that into 2 equal sections, or into halves. Now what we're going to show is 9 halves on the number line, but we're going to show this version of 9 halves. Keep in mind, 4 plus 1 half is the same as 9 half. It represents the same amount. So we're going to start here, and we're going to take one giant leap to 4 whole numbers. So there's 1 whole number, 2, 3, and 4. Okay, so here we are at whole number 4. And now we need to add 1 half. So let's just do one jump to 1 half. And we've landed here at 4 and 1 half. You guys know another way we can express 4 and 1 half is 9 halves. That was so much fun. You guys are probably on the edge of your seat waiting for the secret word, which is Santa. As soon as Cal wakes up from his nap, we are going to take Georgie and Cal to go see Santa. I have a feeling that Cal is going to cry hysterically because when you're 2 years old, Santa can be scary, and I'm going to go ahead and predict that Georgie is going to be delighted and probably yank on Santa's beard. I will let you know what happens on Monday. I hope you guys have a great weekend, and I'm very much looking forward to this short week, but just keep in mind we have some really good work to do. So come prepared for work on Monday, and I'll see you then, guys.